With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Longitudinal waves are produced in 4 identical rods in different situations. Their mode of vibration are fixed points with bold point are shown in the column 2. Their frequencies are given in the column 1 and their wavelength in column 3. Each of the rod has length 1 meter, Young's modulus of elasticity 2 into 10 raised to power 12 Newton per meter square, and density 5 into 10 raised to power 3 kilogram per meter cube. So in this question, we have 4 identical rods in each of which we are producing a longitudinal wave. Then the longitudinal wave, for the longitudinal wave we have been given the frequency, the wavelength, and a diagram that indicates where the mode for different situations of the longitudinal wave form. We have to pick the correct combination. So let's start by trying to find out the velocity of the longitudinal wave. In an elastic medium, the velocity of the longitudinal wave is given by V is equal to Young's modulus of the material divided by density of the material to the power 1 by 2, which means velocity of the longitudinal wave will be Young's modulus is 2 into 10 raised to power 12, so 2 into 10 raised to power 12 upon density is 5 into 10 raised to power 3. So 5 into 10 raised to power 3 to the power 1 by 2, which is equal to 2 into 10 raised to power 4 meter per second. So the velocity of the longitudinal wave is 2 into 10 raised to power 4 meter per second. Now we know that the velocity of the longitudinal wave is equal to the wavelength of the wave multiplied by the frequency. So using this, we will start each of the combinations. So first combination, from column 1 I am picking up the frequency 10 kilohertz. So 10 kilohertz can be written as 10 into 10 raised to power 3 per second into wavelength lambda should be equal to the velocity, that is 2 into 10 raised to power 4 meter per second, which means lambda is equal to 2 meters. So if I look at the table, that means 10 kilohertz should match with 2 meters. So 1 should match with P. So 1 should match with P. Now let's look at the second option. The second one says 15 kilohertz. So that means the frequency can be written as 15 into 10 raised to the power 3 per second multiplied by lambda should give me the velocity 2 into 10 raised to power 4, which means lambda should be equal to 20 by 15 meters, which is equal to 4 by 3 meters. So lambda should be 4 by 3 meters for 15 kilohertz. So that means 2 matches with Q. So 2 matches with Q. Next, we have 25 kilohertz. So once again, 25 into 10 raised to power 3 per second multiplied by lambda should be equal to 2 into 10 raised to power 4, which means lambda is equal to 20 upon 25, which is equal to 4 by 5 meters. So that means number 3 matches with S. So 3 matches with S. Similarly, the fourth combination will be fourth combination will be 45 kilohertz. So 45 kilohertz means 45 into 10 raised to the power 3 per second into lambda is equal to 2 into 10 raised to the power 4, which means lambda is equal to 20 upon 45, which is equal to 4 by 9 meters. So that means 4 should match with R. So 4 should match with R. Now we have to figure out which options from the column 2 match with corresponding wavelengths, and we have already found out which wavelength matches with which frequency, so we will have the correct combinations. The first option in column 2 says second overturn. So second overturn means third harmonic, which means n is equal to 3, which means there will be 3 nodes and 3 antinodes. And they have marked one mode using this bold point. So that means there will be one node here. That means this point is fixed. So this should look something like this. As you can see, there are 3 nodes, 1, 2 and 3, and similarly 3 antinodes, 1, 2 and 3. Now this length that is between 1 and 2 should be lambda by 2. Similarly, this will be lambda by 2, and since this is half a wave, so this will be lambda by 4. So that means lambda by 2 plus lambda by 2 plus lambda by 4 will be equal to, this should be equal to the total length of the rod, that is 1 meter. So that means 5 lambda by 4 should be equal to 1 meter, which means lambda will be equal to 4 by 5 meters. So lambda is equal to 4 by 5 meters. Now 4 by 5 meters was option number S, and option number S matches with 3. So that means one of the correct combinations will be 3, 1 and S. So 3, 1 and S. 3, 1 and S. Next, let's look at the option number 2 in column 2. This says fundamental mode. So fundamental mode means n is equal to 1. So n is equal to 1, and for a fundamental mode the total length will be equal to lambda by 2. Even though they have fixed a mode at the middle of the rod, so the wave would get divided in a manner like this, so that at the middle there is a mode. So as you can see, this will become lambda by 2 divided by 2 and lambda by 2 divided by 2, which means lambda by 4 plus lambda by 4 will be equal to the length of the rod, which means lambda by 2 is equal to 1 meter, which means lambda is equal to 2 meters. So option 2 from column 2 matches with 2 meters, that is P, and P matches with 1. So another combination will be 1, 2 and P. 1, 2 and P. Next, we have third option from column 2. In third option from column 2, between these two modes, we have to fit a fundamental mode. So that means between these two modes, that is these two fixed points, there must be this complete wave. So lambda by 2 should be equal to the distance between these two modes, which means lambda by 2 is equal to 2 by 3 meter as given in the question, which means lambda is equal to 4 by 3 meters. So for option 3 of column 2, wavelength should be 4 by 3 meters, that is Q. So 3 matches with Q and Q matches with 1 and Q matches with 2. So next combination will be 2, 3 and Q. 2, 3 and Q. And similarly, the fourth option of column 2, we have to fit a third harmonic between these two modes. So that means lambda by 2 and lambda by 2, they all should add up to the length between these two fixed points, which is 2 by 3, which means 3 lambda by 2 is equal to 2 by 3 meters as given in the question, and therefore lambda is equal to 4 by 9 meters. Therefore option number 4 of column 2 matches with option R, and R matches with 4. So the last combination will be 4, 4 and R. So 4, 4 and R, which means the correct combinations are 3, 1 and S, 3, 1 and S, 3, 1 and S, 1, 2 and P, 1, 2 and P, 2, 3 and Q, 2, 3 and Q, and 4, 4 and R. So if we look at the options, I can see that only the correct combination is 1, 2 and P, that is option number C.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.